All right, you will also have to be able to perform this procedure with exponential functions. So let's first figure out what they look like. The exponential function is the inverse of the logarithm, and it looks like this. And it has a point on here, 0, 1. And we see that the exponential function is never equal to 0, and it's never negative. So it is always positive. All right, so again, think about the domain first. There's no denominator that can be 0. There's no square roots involved, no logarithms. The exponential function has a domain of all real numbers, so I don't see any way that we would ever be breaking a rule of math with this function. So it's safe to say its domain is all real numbers. All right. Now we can find where it's positive and where it's negative. So start by trying to factor it. The first thing I see is a common factor of e to the x. This first term has 3 of them. This one has 2 of them. This last term has 1, so we can factor out the common amount of 1. So taking an e to the x out of here, if you take one of the e's out of here, you'll be left with 2 of them. Take one of the e's out of here, and take it out of here. All right. Set our function to 0 and try to find the roots. Well, this right here, this equation inside the parentheses is what we call quadratic in e to the x. Meaning that if we were to use a substitution, I'm going to choose u to be e to the x. This will become a quadratic equation. So if u is e to the x, this becomes u squared plus 4u minus 21. We can now factor the quadratic. And then back substitute for u being e to the x. Set each factor to 0. All right, our first factor, e to the x. When does it equal to 0? Well, according to this graph, never. So here, there's no solution. From the second factor, we would get e to the x equals -7. Where does e hit -7? Well, -7 would be some horizontal line down here, and we see that e is never going to be negative. So again, we get no solution. From our third factor, we get e to the x equals 3. So now we need a rule to get to the exponent here. So we need to use a logarithm. Turns out, natural log of e raised to any function in the world, the logs and the e's are inverses, they cancel out, and return the exponent. So to get rid of an e, you must take a log. So taking log of both sides, logs and e's are inverses, so they cancel out. So all we get is log of 3. So this is our only root. Placing our root on a number line, test points. Log of 3, I don't know exactly what it is, but it's some positive number, a little bit bigger than 1. So 0 is definitely less than log of 3. So let's plug 0 into here. Remember, e to the 0 is 1. If x is 0, we would get 1. That's positive. If x is 0, we would get 1 plus 7. Positive. If x is 0, you get 1 minus 3. That is negative. Two positives and a negative multiply to be negative. Pick something bigger than log of 3. I choose log of 4. And remember, e raised to the natural log of 4. The e's and the log cancel out. That returns 4. So, if x is log of 4, we would get 4 from the first factor. 4 plus 7 is from the second factor. And 4 minus 3, which is now positive, for the third factor. The product of three positive numbers is positive. So we can say that f is less than 0 from negative infinity to log of 3. And f is greater than 0 from log of 3 to infinity.